Hello there, it's Chunky Monkey 3001 here, and welcome along to a Let's Build tutorial. Today, Mark and I are going to be showing you how to make the blast door from the engineering section on board the Starliner. So, let's see what we've got here. I've put together this Flatlands map as a download for you, which contains the model of the door which we'll be using during the tutorial, as well as the blank frame. This is at the same starting point as we have in the tutorial, so you can build along with us if you so wish. If you want to download this, hit the download link below, and without further ado, we'll get started. Okay, so here we are at the entrance to engineering, and here is Mark himself. Hello there, sir.
Hello.
Minding his own business, taking care of technical things back here. And everything in order, sir?
It seems so, yes.
Excellent. Always good news. Here is the blast door in question. Regular subscribers will recognise this little beast, and a few of you have been asking for a tutorial on how to build such a creation, so this is why we're here today. Mark, if you'd like to do the honours and toggle the creature.
Of course.
And lo, the technical bits of engineering are revealed. So, we're going to nip over to Nuketown and show you exactly how this thing ticks, and we're going to recreate it. We would show you the original wiring for this, but it's tucked away inside this big thick blast wall here, and believe me, it's cramped up there. So we'll go over where we've got a bit more breathing space, and where everything's laid out nicely for you. Over we go. So here we are in the testing world, Nuketown, where Mark has very cleverly put together this working scale model of the blast door on board the ship. Very nice job too. And this right here is all of the circuitry that was squished into the cavity inside the blast wall. Like I said, pretty cramped in there. So Mark's taken the time to sort of reverse engineer it and lay it all out on the floor here so it can be seen, and we're going to build the thing back up again from scratch over there, or at least that's the theory. So yeah, here's the little brother. I've taken the time to label the different sides, so this here, just to avoid confusion, yeah, this here quite obviously, as it says, leads to the outside.
I see.
If you'd like to press the button there, we can traverse our way through. There it goes, rolls on back, floor comes up, and there we are. And then this side leads through to the outside. As you can see.
I see.
Yes, just so nobody gets lost. And then once we're through, press the button again. Floor goes down, door comes across. There you go. Went without a hitch, didn't it?
Perfect.
As we expected. So, there you go. That's it. That is pretty much the door as it exists on the ship on the way into engineering. Obviously, the other one's made of reinforced stone, is a bit bigger and bulkier, but the principle remains the same. And this here is what's hidden inside the wall, among a few other things. So, instead of staring blankly at this big hulking heap of circuitry and trying to explain it, we're going to build the whole thing again over there.
Yeah.
Obviously, when you build your own blast door, you want to build it out of reinforced materials. This is just for demonstration purposes. You don't have to stick to our design, blah blah blah. But yeah, here we go. So, should we start with the absolute basics? Actually building the physical door itself, or is that where you want to start?
Yeah, probably. Probably.
Okay. So, lead the way, sir. I suppose the first thing is to actually build the track, the area that the door slides through, and then put the door in.
Yeah, that would make sense.
Okay.
Basically, there's not much more to it than the rail and some sensors. Pick up the door position.
Okay.
So, let's start with the motors.
No problem. I shall arm myself as well. I didn't want to do that. I was just about to type motors into the console. It doesn't work.
Not really, no.
If you want to explain the technical bits as we go, and I'll sort of break it down into layman's for anyone who's just sort of starting out in
Yeah.
in RedPower, we should get along swimmingly. You might have to bear with us, guys. This is the first time we've done a tutorial, but we'll see how it goes. I'm sure it'll all be fine.
So first things first, I think the smart thing is to actually start with the door, because it has to be covered with iron covers, and
Of
if you
course.
place the rail before you place down the frames, you will have difficulties to place down the covers.
Absolutely right.
So let's start with the back end of the door.
Okay, so anybody who's just starting out building this sort of thing, these guys here, which I'm placing down now, are frames, RedPower frames. These things can move, actually be pushed physically through the world in any of the 6 directions, up, down, left, right, forward, back. The thing is that they're a bit sticky. We don't actually stick to the sides, but all other blocks do. So as soon as this frame here moves, because this left-hand edge is exposed, all of these iron blocks are going to be moved along with it. The way to prevent that is to use covers. Covers, these thin things here, are a microblock which are included with RedPower. And if you slap them onto the face, like we're doing here, of these frames, they no longer pick up anything that's in front of them. They don't just pick up blocks, by the way. You can pick up other objects. You can also use slightly thicker versions of these covers called panels and sort of start putting circuitry, wiring, all that sort of thing, and that'll be dragged along quite happily with it as well. But that right there is the door itself. That's all there is to it. That's all that's over in this mock-up over here. So when this thing moves, it's actually the frames that are moving, and these iron covers are set into the frames, so they move as well, and they also drag the iron blocks at either end along with them. Just double check the bottom's completely covered. Yes, it is. Okay, that's sealed and ready to go. So how do we move these frames, Mark?
We use this nifty little motors here. I'm holding an end, and you do now as well. And we place them here and here. We get a handy screwdriver out. And when you click it, right click it, you can rotate them. And when you hold shift while clicking them,
Like
you
I'm doing.
rotate them
So
the other axis.
So shift right click, like I'm doing at the moment, will rotate the entire, it will roll the entire motor in a certain direction. And then once it's facing the direction, so that now the bottom's here, the top's there, if I release shift and continue right clicking, it'll just spin it on one axis. So it'll spin it round and round, facing different directions. So I want this to spin that way.
That way.
General rule of thumb, we're using this Fats texture pack, but it's the same in the vanilla texture pack. This wheel in the middle, the gold needle that you can see on the wheel, points the opposite direction to the push direction of the motor. So basically, this one that Mark put down, the needle is pointing to the right, which means anything above it will be pushed to the left when it's activated. I'll also show you a motor sat on the ground out in the open, just to show you what I mean. So here I'm standing in front, I hold shift to duck, and I start spinning the motor on all different axes. And if I release shift, it remains with the bottom down there and the top up here, but spins round to face different directions, so you can orient it the way you want. And you can also see when the top's exposed, you can see the tracks which grab whatever's above it, and the arrow which shows the direction that it pushes in. So the needle's pointing to the right, the motor pushes to the left.
The next part we need for the door is this little platform that comes up and goes down for you to walk over. So we need another set of motors. Place this way. this away. Like this.
Okay.
And we need another set of frames. This. And like this.
So again.
Oh, no, like this.
Yeah, there we go. So.
Oh.
Sorry. We'll cover this one in covers.
Okay.
Oh, you already got there.
One last thing, we need a... Here? Yes, I think it's here. An iron block on this side.
That's
This will be
very
the yellow
important.
sensor part.
Yeah, that will become very important a little later. Right, so I'll go ahead and just put the floor in. So
And basically the rail goes all the way to the back.
Alright, so as you can see, the bottom of the door here, we'll leave that uncovered actually. The bottom of the door here will slide along this block all the way to the back, like Mark said, by which point, hopefully, this part of floor won't be here. Obviously, modify this to how you want it. The floor part which rises and lowers in the real ship is a lot bigger than that one. It's just for demonstration. You don't have to sort of hop, skip and tiptoe over and bash each other in midair as well. Okay.
Okay, just lay down some walls to the left and to the right.
Looks good.
Encase it a little more. Like you said, this is just aesthetics. Nothing to do with the function of the door itself. Basically design this as you like.
Right. So now
now
we get to the meaty part, the wiring. So
oh.
let's clear my bar out. So
Okay, I think the next important thing to show are the block detectors we're using.
okay. I'll just show on the example here. There's the motors that we just placed. There's the frame for the floor, the door obviously, and the door motors. So this is what we're doing next. This part here and this wire coming out here. Okay, so which one do you want to start with first? Should we start with this open sensor?
Yeah, let's start with this one. So the basic idea is that you provide a redstone signal. I'm personally using this inverter. You could use a redstone torch as well, but I think those look cool.
Absolutely.
Looking things. And on the other side, you place down a repeater. A simple redstone repeater. And this repeater will pick up the redstone signal provided from the other side of the block. And the idea is now, when there's no block between those two, there's no redstone current flowing. So as soon as a block hits the spot, redstone current flows. And there you have your block detector,
Nice and
which
simple.
we'll use to pick up the door position.
Absolutely. So yeah, nice and simple. So as soon as the door slides all the way back to its home position here, open, it completes the circuit. And then that's picked up by a wire which goes here, which is, let me see now, orange. So let's get the wires. So there's the bundle cable, there's the wire. Haha, we have a signal. Not going anywhere, but we've got a signal. So
that's a beginning.
Absolutely right. So let's get the repeaters and the inverters and put in the rest. So the next one goes in there. This is the one that detects when the door's fully closed. So remember that the door frame is going to slide all the way through here, butt up close to that wall. So there, and of course it's facing the wrong direction. Where's my trusty screwdriver? There we go. Do it to a repeater there. And that wire is black. So get my black insulated wire. And here's a bit of a cheaty way. Smash a bundled cable and pick it up. And then it's in my inventory. There we go. Cool. So that block that we put onto the side of the platform that goes up and down is for this circuit here, which marks wiring in now. That detects when the floor is in the up position, and then when it lowers, this block completes this circuit for the lower position. Okay, so our 4 wires so far that we have going into this bundled cable: orange for the open sensor, black for the closed sensor, and then for the floor platform, green for raised, yellow for lowered. So next, I suppose we need to wire in these motors.
Okay. So, this is rather trivial. Blue, light blue, white, and red.
Okay, well I'll take the 2 blues. Blue and light
White,
blue.
red.
So let's take a little look. Yep, light blue goes on the left, which is the motor to close the door. Bearing in mind this motor is going to move the door that way. And then dark blue, or regular blue, I should say, to open. And there we are. White to lower the floor, red to raise the floor. So those are our 8 colours. Oh no, there's a 9th colour, isn't there?
Yeah.
Wonderful fetching pink. Get some red alloy wire. I think I'm being slightly silly. Yeah, I'm trying to put it where it doesn't work. And here. There we go. I'll hit a couple of buttons. One there. And one there for our door controls. Okay.
This
So,
looks very good now.
that's the actual working model setup. Next.
One thing's missing though.
Oh, what's that?
Yeah. These motors need power.
Of course. How silly. How silly
But
to
we
forget
have
that when
already prepared something.
I'm the one that put these down and I completely forgot. Okay, so back to basics. These motors, like Mark says, need power. One method of getting power in RedPower is these solar panels. Create a solar array like this, place them next to a couple of battery boxes, which take all their juice from the solar panels, then use these blue electric cables to take the blue electric current to the motors. And you can see they're just starting to light up now. There we are. Ping! And they are now powered. So when they receive a redstone signal from these wires, they'll kick into life and start creating some magic. Hopefully. That's the theory. Right then. Yes, thank you, Mr. Cow. Next up, the logic. So, onwards to the next part. The tricky, logicy bit. So, what next?
Okay. For the logics, we need some basic understanding about what's going on over here. And I think we should start with the concept of so-called state cells.
Okie doke.
These will basically keep track of the actual status of a door, whether it's moving, what part is moving, and so on. So we can keep track of this. And to do so, we need this little fellow here, called an RS latch.
Okay.
It's basically something like a 1-bit memory cell. If we place it down, put a lamp, both outputs, and a lever on both inputs. When I flick this lever, the state of the RS latch changes. So it saved that I flicked this lever.
Okay.
Switch this off, and with this lever, I toggle the state of the RS latch, and now this position has been saved. Yeah.
Yeah, 'cause-
So for the actual door movement, there are 6 different states we have to keep track of, I guess. Being door moving to the right, door moving to the left, and this little platform moving up and down, and no state is also a state that we have to keep track of.
okay.
No movement at all. Let's say our grey, light grey wire here is the actual command to close or open the door. To prevent weird things from happening, we will add a pulse former. Basically just makes a pulse out of a continuous signal, and it also works as a diode, which means that it just lets the redstone current pass in one direction and blocks it from the other direction, because those RS latches produce outputs on the input side, which is kinda irritating if you don't know it. This be your input, and the RS latch. There's
Yes.
something else tricky about them because we have to rotate it.
I have my
With-
screwdriver at the ready.
let me see. It's quite difficult to get the correct setting. I think this is it.
Ah, we discussed this earlier, didn't we?
Yeah.
Basically, the reason that this now looks like a completely different component is because there isn't actually a texture for the inverted RS latch. Basically, the RS latch as it exists, let me just get one out to demonstrate. RS latch, well, there it is. The RS latch as it is with the screwdriver can be rotated much like the motors, which is what I'd originally done. But what Mark's done is held shift, which flips the RS latch the other way, essentially disconnecting that wire, this red wire, from this side and reconnecting it here, and vice versa on the other side. So basically you can have the torch on the right activated and this rail at the same time, like you can see here, and you do that by holding shift and right clicking. There you go, happens eventually. But unfortunately the texture is missing. That's why it looks like a different component. But if you see one of these guys, these blocky fellas, it is an RS latch. It's just flipped the other way for what's the word I'm looking for? Not for convenience, but for functionality. That's the one. For functionality.
Yeah, because we want this output to be on when this input comes. Oh, this one. When this input is on, we want this output to be on. Because here we will attach a timer and set it to something around 800 milliseconds.
Okay, so for those who don't know, the timer is basically something that continuously sends out a redstone pulse from the front end, the front with the little squat redstone lamp here, after a set duration. Here you go. So that's sending out red pulses. What's that? Every
This is every
half a second
now.
That's every second. The difference is if it's powered from either side or from the back, it stops, which is why this one isn't flashing at all. There you go. As Mark's just demonstrated with that lever. Lever goes off, timer activates.
Okay, now this timer will then control one of the motors. You have to tick continuously to make the motor move. Otherwise, it will just move once and then stop doing.
Yeah, that's something I didn't mention. Each redstone pulse to a motor moves whatever's above it by one block, so these guys come in quite handy.
Okay, and this will be fed into a white wire. Cause white. See, we'll actually move the platform down. We want to toggle this off as soon as the platform reaches the floor. and this will activate this sensor down here. So the other side of the RS latch has to be connected to a yellow cable.
Ah, okay, it's starting to make sense, a bit more sense to me now as well.
And the whole RS latch thing is to prevent the malfunctions caused by lag. You could also imagine setting up timers and waiting for a certain amount of time and then switching off the signal. But especially in multiplayer platforms, this is very unstable. So it's better to use those sensors and actually keep track of the state of the system with those latches.
So would I be right in saying that most of this system is a repeat of that circuit there?
Yeah, exactly. This is
Ah,
1, 2, 3, 4 of those in a row.
okay.
Because now we just feed the yellow signal, this one, the sensor signal, back to another RS latch. No, that's the wrong part. It is this one. And we toggle another RS latch this way. And this one, correctly, will then enable, where is it? This timer, which will finally move the door itself. I think this latch is still wrong. Okay, so when the platform hits the floor, yellow cable gets a signal, disabled this RS latch or toggles it, so this output is disabled, and then this timer here will start ticking. And we also set this to 800 milliseconds. This arbitrary value turned out to work quite good with the motors. They need, I think, 400 milliseconds in single player for one movement.
Okay, so the next circuit here is an absolute carbon copy of that one. So I might as well go ahead and lay out the next lot of the circuit for you. So
Sure, go ahead.
Got the RS latch, got timers, we've got repeaters, and we've got pulse formers. Anything I've missed? I think that's about it. Alrighty. So, copying exactly, we've got that right there. Set 0.8 of a second. And the latch. Which goes there, is that right? No, it's not.
No, it's not.
There we go.
That's right.
Okay, cool.
No. Wrong again.
Really?
What? Is it? No.
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 No, it's not. Don't try and catch the new boy out.
I'm just being silly.
Okay, we're set.
Okay. I finished this one over here by adding a black cable, which corresponds to this sensor over here, which is the door closed sensor, to switch off the whole system, and a light blue cable here, which controls the motor that moves the door to the right. So let's go through it step by step, I guess. So, to state it, science starts the process. And we want the platform to go... I'm confused as well. No, we want to...
we want the door to start first, don't we?
move. Yeah, we want the door to move out of the way first. This is done with the blue cable. And The blue cable moves the door over there, so we have to look for the orange signal to stop the process. So when we get a signal from orange, we know the door has completely opened. This switches off this part,
Okay, so we start
and
off.
also start off this part. And this timer will move the platform up, which is red. Blood red. Here.
You can see the platform's
Ah.
correcting itself.
Now it's in the upper state. And the process is terminated by this final sensor,
Which is green.
which corresponds to green.
Hey!
And it stopped. Perfect.
Yay!
Next thing we need to test is to prevent any mess from happening. If the door is already moving or not when you hit the button. Because we don't want any state changes while the door is switching state.
Absolutely right. That was something I meant to ask you, actually, if there's any sort of protection for people spamming the button.
It is. Okay, what we will do is we use another RS latch to monitor if the door is moving or not. That means we know that when we press the button initially, the door will start moving. So, get this pink cable here, which corresponds to button being pressed, and feed the input to a RS latch. We feed the output directly back into the system with this darker grey cable. And this should be, yeah, perfect. The right state from the beginning. Yes, it is. No rotating this time.
That's useful.
Cool. And we know that when the door hits the completely closed state, which corresponds to the black cable, and when the platform is up, which corresponds to the green cable, then the process has stopped. So we need to look for the green and the black signal, and we feed them into the other side of, oops, this cable, what with this cable, and feed it into the other side of the RS latch. What is this connecting? Oh,
You need a panel strip.
exactly.
Or a cover strip. Just there.
That's
Just
another
to cut the
thing.
circuit off.
Like this.
Hey!
Okay, now, when you push the button, this RS latch toggles, and the grey output is set enabled to notify ourselves that the system is running, and when either the black signal or the green signal is activated, we toggle the RS latch to this side, which disables the output. So we will keep track of whether the door is currently moving or not, and it's just a matter of getting this grey cable and the pink cable.
Okay. So it's the dark grey cable that's in charge of basically telling the system whether the door is currently doing something. Okay. Okay, so the last part now is the controlling whether the input from the button goes through the cyan or the light grey cable, is that right?
Yeah, we just toggle the signal. Now we use a NOR to invert the is running output and feed it into an AND gate. Use a screwdriver. A So basically we want to disable the input as soon as the door starts moving. So as long as the grey cable is disabled, we want the second input of our AND gate enabled. And when the door moves and the grey cable is enabled, we want the input for the AND gate disabled.
Okay.
Since we're only using 2 of the 3 inputs of this AND gate, we disable the third one by just shift clicking it. And you see this light switches off, which indicates that this input is always enabled, so to speak, or
Ah,
completely
I never knew that.
taken out of the system. That's quite handy, because usually you don't need the third input.
Yeah.
It's quite annoying to override it by feeding a second signal into it or something like that. Okay, and this combined signal is then just fed into a toggle latch, which does exactly what it's named after. It toggles states when you input a redstone signal.
Absolutely. It's kind of like a vanilla redstone lever with 2 redstone outputs coming out of it, really, isn't it? Well,
Kinda.
combined with a NOT gate, and it's switchable by a redstone input. It's nothing like a lever. It's nothing like a lever at all.
It has a little lever on it.
Yeah. Yeah, there you go. You can see by the redstone line through it that if a redstone input comes from either that side or that side, it'll flip this little lever, like Mark says.
Okay, it has to be in this position. You have to be careful, you have to look at the position of the door and then try to manage to find out which position the lever has to be in. Just take this circuit as a reference. It has to be in this state for the door to be open. So, with the cyan and the grey as inputs to start the opening and the closing process. So again, we're using pulse. So this is a little redundant, I guess, but it doesn't matter.
All
Rather
right.
using too many diodes than having a signal backflow into the system, which is always the worst thing that could happen.
Okay. So that's us complete.
Yeah, I think so. The last thing missing is this piece over here, which is clearly just for statics.
Just for effect.
Just for effect. Can use this for moving signal, this grey cable here.
Oh,
Uh,
I think you
for
might have the
some.
wrong grey.
Okay. Oh, tricky.
Yeah, you want the dark grey. This door is doing something grey. There we go.
Ah, yeah, this is correct. This dark grey cable, which indicates that the door is moving. We just connect it to alarm, and also with redstone, vanilla redstone, of course cables don't work in this case. We connect this signal to signal controller box. Here.
These guys aren't necessary, but they come from a couple of different mods. The signal controller boxes and the lamps that they connect to come from Railcraft. And is it the Industrial Craft Nuclear Control, isn't it? Industrial Craft Nuclear Control mod has these howler alarms, which are used to.
Mm-hmm.
That's right, nuclear control. That's where that one comes from. Everything else is RedPower.
Oh, and I'm using those they're called distance signals. And you also need something called a signal tuner. You right-click your signal controller, right-click the signal, and there they're connected to each other. You do the same thing with the other signal controller box with the signal lamp on this side of the door. And now both are connected, both are showing green light. You can pass through this door here. And now, hopefully,
Fingers
it
crossed.
screw up. Then if I push this button, well, almost.
Almost everything worked.
Almost. Feeling that this messed up something over here. Replace this with a repeater. Should now work in theory. Did I manage to screw out this RS latch state?
I'll give it a try. There we go.
Okay, it was this repeater.
What was...
Should have stuck to the original plan.
Ah, okay.
Now it's working.
Did you change something on the fly?
Yes, this was a pulse former before, and now
Ah.
I replace it with a repeater.
How strange.
For some odd reason, this solved the problem.
Okay.
It was
So
the...
stick your repeater here instead of a pulse former. But there you go. That is the door. Mark, if you want to go and just press the button if you wouldn't mind. I'll just keep an eye on the circuits so you can see all the intricacies of everything running through. Has the alarm stopped again?
Oh, you can't be serious. This is stupid. Over here, this is kind of a giveaway. This signal is always on. Over here. This repeater is on.
Yeah.
And this is blocking the RS latch from talking. So those two have to be... where are they? Those two have to be pulse formers. Now this is correct. Now it makes more sense.
Understood. Understood.
This is why you need pulse formers to input into your RS latch in the first place. And now it should be howling on both closing and opening state.
Howling it is.
And just to prove it, now it's doing it on the closing state as well.
Beautiful.
There we go.
So there you have it. That's all that it took. Simple, eh? Mark, you've once again amazed me and slightly confounded me, but at least it makes a bit more sense to me as well. Hopefully it makes a bit more sense to some of the guys out there that were wowed by your prowess of creating this thing in the first place.
I hope so.
Where have you gone, good sir?
I'm floating up here.
Oh, there you are. Come and take a bow for your work. I think. Okay, well, thanks very much for joining us. Hopefully this has been informative and not complete rambling rubbish. And if you do build any of your own creations based off of this, or use it for something different, perhaps you could use it for, I don't know, a drawbridge or some sort of moving platform or something. Possibilities are endless. Then send me a message, or if you make a video, upload it, then drop it in as a video response. It'd be great to see what you're up to. Thank you very much, Mark.
Sure.
And
pleasure.
We shall see you again. Take care, everyone. Bye-bye.
Bye.